This is my prototype Arduino laser rangefinder. It is very ugly and hastily put together, but it works. We have here a SmartFun Arduino Pro MIni, and on this side we have a little breakout board. This is one of our Arduino-powered breakout boards, and it holds a Stonyman image sensor chip with a cell phone lens, and we see here a little transistor. What happens is that the Arduino is able to turn on and off the laser. The principle of operation is very simple. The laser turns on and off, and when the laser is off, the Arduino takes a picture. It basically grabs 3 rows of 32 pixels, not very many pixels, and then the laser is turned on, and the Arduino grabs the same image, and then it just compares and sees which pixel changed in intensity, and that's the location of the laser point. Now, in this video right now, we have the laser turning on and off at a very slow rate. This is just to show you a video, but I can turn the speed up. So now there is about a 10 millisecond delay between when it turns off or turns on and when the image is grabbed. So first we'll start out at a very short range, and you can see right here, at this very short distance, this is less than a foot, pixel number 2, pixel number 3 is being lit up. Using the geometry of the lens and the distance between the sensor and the laser, we can convert that to a distant measurement, but for now I'm just going to tell you which pixel is lit up. So as I move away, pixel 6, pixel 7, 8, 9, 10, 11, 12, 13, 14 is lit up, 15, 16, 17, and you can see here by knowing which pixel is lit up, we can get an estimate of the distance. Now when I aim it at this corner over here, this is about 7 feet away, and pixel number 23 is lit up. At 14 feet, it's still detecting it. Pixel number 24 is lit up. Now, if I shine the laser at this far away corner, this is about 26 feet away. Pixel number 24 is still lit up. What that means is that the disparity is basically the image sensor and the laser are not far apart to really be able to detect the change. The baseline needs to be larger, but at least we know that the laser can pick up. That the image sensor can pick up the laser at that distance. There are, of course, a number of ways we can improve this. We can increase the baseline, the distance between the image sensor and the laser, and that would let this work over a greater distance and allow us to resolve a greater distance. We could also use a telephoto lens. That would make the pixels closer together in the visual field, also increase the distance at which we can resolve different distances. We could use a brighter laser. That would extend the range a bit, of course at the cost of weight. We also have a little bandpass filter. I'm not using it here, but it's an optical bandpass filter that's tuned to let through just the laser light and block everything else. And what that would allow you to do is to use this in a brighter room. We've actually used this in a sunlit room. It doesn't work outside, but a bright sunlit room, it will work there. We can improve upon the analog signal quality, make the voltage regulator, use better voltage regulators, and get a very clean analog signal. And finally, we can more tightly integrate everything. I bet you, using this laser module, which weighs about 1.9 grams, we can make the whole thing weigh maybe about 4 grams. Stay tuned.